All right, so that look it was just kind of get you guys remembering all of the postulates from last week. So just quick review. In order for two triangles to be similar to each other, what two conditions have to be met? So in other words, similarity, that means what? What does similarity mean? Same shape, different size. So what does that mean in terms of its angles and sides? Congruent angles. What about the sides? What's their relationship?
They say the same thing.
What's the word for it? Say it again? Proportional. Good. So remember, angles are congruent, sides are proportional. All right, meaning that if you put the corresponding sides one over the other, it'll equal the same proportion as if you put another set of corresponding sides one over the other. All right. Now, what is one of the three postulates that we learned to show if two triangles are similar or not? What's one of them? Say it again. You say SSS? Right, so side, side, side. So remember, that's when all three sides are equal to the same proportion. What's another one? So there's two more. What's another one? SAS, so side angle side. So one angle between two proportional sides is congruent. What's the last one? Angle, angle, or angle, 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 however you want to put it. So that just means all three angles are congruent, or at least two of the angles are congruent. Because remember, by the third angle theorem, if two angles are congruent, we can assume the third is as well. All right. So today we're delving a little bit deeper into different theorems that are formed by similar triangles. So 2.8 split up into three different parts. So today we're learning about the side splitter theorem. Now, just a reminder that for this unit, because it's super duper short, we'll probably be done with this unit by Wednesday. So we'll review Thursday, test Friday. All right. Those journal entries, same thing as the last one. You're just going to be copying what's posted in Canvas. That stuff should be posted by this afternoon. So you can go ahead and get a start on that. Make sure you also do your vocabulary. There's only like 4 to 6 terms, I think, off the top of my head. So it shouldn't be too hard. Oh, so the homework key, like I took it straight from the website that I got this from. So it's like the bulk stuff in the boxes. Like, let me see what I pulled up. So yeah, the homework key, if you scroll down, this is the stuff that's in the boxes is the answers. Yeah. I didn't have time to make my own, so I just took the original that they had. All right. Now, that being said, remember what I said about the 2A test, because I know some of you were asking me about test corrections. I'm technically not doing test corrections for 2A, but what I am doing is on your 2B test, about a little over half of that test is going to be congruent stuff again. All right. So before we get to test day, I'm going to have you guys go back and look at your 2A test. It'll probably be Wednesday when we do that. And I'll have you guys look at what you did, fix it, so that you'll be prepared for that Friday. So how it's going to work is that there's going to be part congruency stuff, part similarity stuff. I'm going to give you a sub score for the congruency parts, meaning I only grade the congruency parts, give you a score for that. If that grade is higher than your original 2A grade, I'll replace the grade. All right. So it's almost like a redemption grade for the 2A test.
So, like, if we do worse on the 2B, like, you won't have to.
So if you do worse, I won't change the grade. So just give what you originally got.
But if we do better, are we just getting other replacements or looking at your replacements?
So 2B is going to be split into two parts. You're going to have a 2B test grade and the 2A replacement grade. All right. So I'm going to score only the congruent stuff on its own. That sub score is going to go into towards your replacement grade if it's higher. And then the 2B stuff is going to be graded, and then that's going to be its own test grade. All right. Does that kind of make sense? So again, I'm going to give you guys time to look at your tests later on this week so that we can go through and talk about some of the most missed problems, things like that. All right. Okay. So getting into what we're doing today, like I said, the side splitter theorem. It's one of the theorems that comes from similar triangles. All right. So the main theorem with the side splitter theorem is we see how line. Oops. Come on, you can do it. All right, there it goes. So today we're specifically going to look at how lines drawn parallel to a given side in the triangle will divide the other two sides. Why is this being stupid today? Sorry guys, my computer's being dumb today. All right. So first things first, in this diagram shown of ADE, points B and C lie on section AD and AE such that BC is parallel to DE. So BC is parallel to DE. That's why they have these little arrows, tick marks here that's showing parallel. All right. Now we're going to justify that ABC is similar to ADE. All right. Sorry, guys, my pen's just being really, really dumb. There it goes. All right, so looking at this, we need to pick one of the three theorems or the postulates in order to prove similarities. We either need to use angle-angle, SAS, or SSS. All right, which one can we like automatically throw out that there's no way we can use? Look at what's given to us. Which one can we like just automatically throw out? There's no way that we can use it because we don't have enough information. Side, side, side. We definitely can't use side, side, side because we don't have side links right now. All right, they give this to us in part B, but if we're just basing it off of what we currently have in part A, we can't do that yet. What's the other one that we can't really use yet? Side, angle, side. Again, we don't know the side lengths. So we're going to have to use angle, angle. All right. So that's where these parallel lines come in. So we need at least two angles that we can show that are congruent. What is at least one angle that I can absolutely right off the bat say that's congruent? Say one more time. B and D. So I can say that B, I can say the angle B and angle D are congruent. Why can I say they're congruent? Right, because they're corresponding angles. Meaning, since the parallel lines cut by a transversal, they're in the same spot, so they're corresponding. What's another pair? C and E. So we could say that. Why are you being dumb today? Sorry, guys, my pen's just being really, really dumb. Okay. All right. Guys, give me a second. I need to restart my computer because it just completely. There it goes. Let's see if it works now. There we go. Okay, so we can say angle C is congruent to angle E, again, because they are corresponding. Now, that is enough to say that triangle ABC is similar, remember the squiggle just means similarity, to triangle ADE, and it's by angle. Now, how can I show that angle A is congruent? Like, let's say I didn't realize that one of those two that we already found was corresponding. How could I say that angle A is congruent? It's the reflexive. So we could also say that angle A is congruent to itself because of the reflexive property. So as long as you stated 2 out of those 3, you could have easily shown that that was similar by angle. Now, the next part says that angle AB is equal to 6, not angle AB, side AB is equal to 6, side AD is 10, AC is 9. And it wants us to solve a proportion to find the length of AE and CE. So, AB is 6, AD, so this side right here, is 10, and AC is 9. And it wants us to find the length of AE, so we'll call that X, and CE, so we'll call that Y. So, first off, we know the sides are proportional. So, which variable would be the obvious one to solve for first, X or Y, given the information that we have? So, guys, Y is only a part of a full side. It's not even part of one of the triangles, all right? So it's not like a full side length of one of the triangles. However, X is. So since we have 6 and 10 for AB and AD, we can figure it out for AC and AE, because remember, those two are proportional. So if AD over AB has to be equal to AE over AC. So how would I set this up using the information that I got? What's the length of AD? 10 over what? 6 is equal to, what's AE? X, and then over 9. So we can cross multiply to get an equation. So this would be 6x is equal to 90. And then 90 divided by 6 is what? 15. So AE is equal to 15. Now, how can I use that information to give me CE or Y? Right. 15 is the whole, 9 is a part of the whole, CE is the other part of the whole. So if we do 15 minus 9, that'll give us Y. So Y is equal to what? 6. So that is CE. So this is equal to 6. Now, let's look at when we compare some of those lengths. So if we do AB over BD, first off, what's BD's length? What would BD's length be? 4, because 10 minus 6. All right. So we would have AB, which is 6, over BD, which is 4. Then AC, which is 9, over CE, which is 6. Now, if I simplified these two fractions, what would the first one be simplified to? So AB over BD, 3 over 2. What about the second one? What's it simplified down to? 3 over 2. So what do you guys notice about this? Right, so these proportions are equal. Now, if you notice, all we did was take the sides of the smaller triangle, which is also part of the bigger triangle, and then the other part of the bigger triangle that forms like what appears to be a trapezoid. All right? And if you put them over each other, the proportions should be equal. All right? And that's exactly what the side splitter theorem is. All it says is that a line drawn parallel to any side of a triangle that intersects the other two sides will divide them proportionally. All right. So that means AB over BD will be equal to AC over CE. So another way to put it is that, let's say, if I just color code these for a second. All right. Let's say red was X, Y, Z, and W. So what this is saying is that if those two sides, so BC and DE, are parallel to each other, so BC is parallel to DE. Because of that, we know those two triangles are similar because of angle. So because of that, as long as we have at least 2 out of those 4 sides, we can easily find the other 2 because X over Y has to be equal to Z over W. They're proportional to each other. That's all that means. So now, given BC is parallel to DE, we're going to algebraically prove the side splitter theorem. So first off, if we just did this as a proof, okay, statement and then reason. First things first is that BC is parallel to DE. That's just our given. So they're parallel. Now, we need to prove similarity first. So we're going to do what we did up top and go ahead and state two of our angles being congruent. So I'm going to say that angle B is congruent to angle D, and just for room's sake, angle C is congruent to angle E, and it's because corresponding angles of parallel lines are congruent. So these two angles are congruent, and these two angles are congruent. Thus, we can say triangle ABC is similar to triangle ADE because of angle. Now, because of that, we can say that AB over AD is equal to AC over AE. So those two sides are proportional. And that's just because that's the definition of similarity. Sides are proportional to each other, and those proportions are equal. All right. Now, because of that, we also know that AD minus AB is equal to BD, and AE minus AC is equal to CE. That's just by segment subtraction. So, algebraically speaking, if we know that these are congruent to each, not congruent, that we have our proportion, all right, and we also know that if we were to subtract them, so let's say we did, let's say AB, or we can also say it as addition, AB plus BD is equal to AD. All right. AC plus CE, not CE. Yeah. Why did I write like that? Okay, we know those sides added together will give us that proportion. So, from here, what do you think I would do? All right. Now, think about proportions, guys. We're technically dividing, right? Right. So, if we divide, what's kind of another way for that? So, we're saying that if we divide, which I'm going to change this real quick, but I'm just going to flip these. So, AD and AB, AE and AC. So if we're dividing the bigger by the smaller, all right, and I know that I get B, D, and CE from there. Wouldn't it stand to reason that if I multiplied them, I would get the same thing? All right. So we can also say that if we do AB times BD, that should give us AD. All right, same thing with the other one. And let's see if that works out numerically. So let's say we used what we had up top. So they had 10 here, 6 here, and 4 here. All right. And then here they had 15. Okay, you know what? We're going to put a pin in this proof because I'm just completely blanking right now. We'll come back to it. All you got to know is mainly this. I don't want to confuse you guys more, but you just need to know that. Okay, that's the main thing. I can see it on your faces. I'm like, we're just gonna, nope. Okay. So let's look at some examples with this. So all it's saying essentially is that if you split the sides, they're proportional to each other. Okay. So the following diagram, RU is parallel to SV, which is parallel to TV or TW. So these three lines are all parallel to each other. VW is 6, RS is 15, TZ is 25, and WZ is 15. And they want us to find these two sides. So we're going to call STX and UVY. So if we use the side splitter theorem, all right, you typically want to use sides that come from a triangle. So here's our big triangle. If you do side splitter theorem, you typically want to have one of the sides of your proportion coming from your little triangle. All right. So for this first one, I need to find the proportion from TZ and ST. So we're technically doing these two triangles. All right. So I'm going to start by using ZW over VW. All right. They're from the same side, just two different parts of the triangle. And it's going to be equal to TZ over ST. So if I just substitute in the values that I already have, what would this proportion be? So we already got all of these values except for one. So if I just substitute in those values, what would the proportion be? Or just what would it be if I substitute everything in? So it'd be 15 over 6 is equal to what? 25 over x. So to make my life a little easier, I'm going to simplify the 15 over 6 before I do some cross multiplication, just to make my life easy. All right. So if I do 15 over 6, what does that simplify down to? 5 over 2. It's equal to 25 over x. Then I can cross multiply. So I get 5x is equal to 50. So what would x equal? 10. So we're saying that x right here is equal to 10. Well, let's see if that holds up in court. So we know 15 over 6 simplifies down to 5 over 2. Does 25 over 10 simplify down to 5 over 2? Yes. So that works. All right. Now, for y, what would be the two side lengths equal to what two side lengths? So if I want to find y, what two side lengths do you think I should use? So I would still start with using from the purple triangle. All right. Always use sides that are flat out given to you from at least one of the triangles. We could have also added up the sides from to get SZ and VZ, but the only problem with that is that for whatever reason, if you got ST wrong, it mess up your calculation. So always use your given information as references. All right. So we're going to start with what we started off with the old one. So TZ over ST. Oh, no, my bad. I mean WZ. So I got WZ and TZ. Those are my definites that I'm already given. And I'm trying to find UV. So would UV go with WZ or TZ? WZ, it's on the same side. So what would go with TZ? What part of the triangle, red, purple, or green? Green. So it would be what side? RS. All right, that's how you look at it. If it's easier to color code it, because there's like 3 triangles in there that are all similar to each other, go for it. Okay. So that means I would have 15 over y is equal to 25 over 15. And again, I'm going to simplify 25 over 15 just again to make my life easy. So 25 over 15 will simplify down to what? So I got 15y is equal to what? 5 over 3. Cross multiply. 15 times 3 is 45, which is equal to 5y. So y would have to be equal to what? 9. So this side here would be equal to 9. And if we check, 15 over 9 does simplify down to 5 over 3. So guys, again, the way this works is we typically want to use your similar triangles. So if we're talking about ST, for example, you want to use one of the triangles that they already gave you that's not part of a bigger one that's split up. So we're going to use the small purple one and then the red one, which forms the purple one when it's split in half or just split down the middle. All right, that's how we would set up proportions. So it would be side over side, side over side. Okay. Same thing here. We use the small triangle again, but we use the green part of the big green triangle. We could have also done, say if we added both of these two and did it over that, it would have worked out the same way. So if I did that, say I add this up, that would have been 35 over 15 would be equal to 6 plus 15 is 21 over 9. Simplify both of them down, that would be 7 over 3, 7 over 3. So it doesn't really matter which ones you pick as long as they're part of the same type of triangle. So if you pick the red triangle to use with the green triangle, then you need to add up the two sides. All right. That's why I say use the smaller ones. You don't have to do any extra work. All right. Does that make sense? All right. All right. So let's try this one. So AE was partitioned into the lengths 2, 3, and 5. So 2 here, 3 here, 5 here. The line segments are drawn parallel to ED. If AD is 30, so this entire thing is 30, then AB, then what is AB, BC, and CD? All right. So if we start with this, all right, we got all of our sides here. Now, we know that the entirety of AD is 30, and then we got the partition of the other side. Now, what would this side all be equal to? So if I add up all three of these side lengths, so 2 plus 3 plus 5, what would it give us? 10. Now, currently, right now, we don't have enough information to use side splitter theorem yet. But we can still use similar triangle theorems. All right, specifically the sides are proportionate to the other. So, given the triangle AED, which side length would be the easiest to find? Just knowing the fact that they have to be proportional. So I'll give you a hint. We're using the proportion 30 over 10. Say one more time. Yeah, you would times by 3. So, or in other words, let's say I found AB. Because we know they're similar triangles, AB over 2. All right. Simplify that down by cross multiplying. I would get 10 AB is equal to 60. Divide by 10, AB has to be equal to 6. So that one we could have found just from using the fact that two triangles are similar. So these two triangles, well, that triangle and the big triangle. All right. Now we got enough to use side splitter theorem. Okay. So using the 2 and the 6. So we're going to do 6 over 2. Let's say I was trying to find BC. how would I set up the proportion in relation to 2 over 6 or 6 over 2? So let's call BCX, and it'll be over what? 3. Multiply it together, I would get 18 is equal to 2x. So x, or let's say BC, would be equal to what? 9. Now let's double check if our big triangle similarity still holds up. We know 30 over 10 is a big triangle. Well, let's see if we look at this triangle. So we have 2 plus 3, that's 5. 6 plus 9 is 15. If I do 15 over 5, does that still give me 3? Yes, so we're still holding up. Last one, let's still use 6 over 2. So 6 over 2, and I need 5 somewhere, and then CD somewhere else. So how would I set up that proportion? So it would be x, let's call it y so we don't get confused, over 5. Multiply them together, I would get 30 is equal to 2y. So y would be equal to 15. So that's also CD. All right. And again, if we check the similar triangles, let's say if we checked it against the 15 over 5 one. 15 over 5 is 3. Oh, son of a. And 30 over 10 is 3. I think it's whenever somebody else joins it, it does that. Okay. So this kind of leads into the converse of the side splitter. Okay. So we got all 3 of our sides here. So here, here, and here. Those are our new side lengths. So a line or a segment that divides 2 sides of a triangle proportionally must be parallel to the third side. So in other words, if all 3 of these triangles are proportional, yes, ma'am. Yeah, you could have. I just wanted to show it with side splitter theorem because it wouldn't have ended up that nice sometimes. All right. So yeah, what Sutton said, you could have also done it by scale factors. If you notice that it was a scale factor of 3, you could have done it that way. Now, because all of those sides were proportional, we could conclude that all 3 of these lines are parallel. All right, so sometimes they'll give you the proportionality, but not the parallel. Sometimes they'll give you the parallel, but not the proportion. Okay. So we're going to verify that AB over BC is equal to AD over DE. So if I plug in the side lengths that I have over here, I have 10 over 8 is equal to 15 over 12. If I simplified both of those down, would they be equal to each other? So what is 10 over 8 simplified down to? 5 over 4. What's 15 over 12 simplified down to? Right, 5 over 4. So they are congruent or equal to each other. Now we also need to check that AC over AB is equal to AE over AD. So first off, I need to find what AC and AE is. So if I add AB and BC together, what does that give me? 18. What about AD and DE? That'd be 27. So if I plug everything in, I got 18 over 10 is equal to 27 over 15. So if I simplify 18 over 10, what does that simplify down to? 9 over 5. What about 27 over 15? 9 over 5, right? So that's true. What do you think the common ratio would be? So let's say that I started with ABD and I wanted to dilate it by some scale factor to give me ACE. What would I need to multiply it by? We kind of already found it. So, how would you typically find a scale factor if you didn't know it, but you knew at least one set of the sides, corresponding sides? You do the new minus, not new divided by original, right? Didn't we already do that? So, what's the scale factor? 9 over 5. So, our common ratio is 9 over 5. So if we wanted to give a dilation that would show that ABD is similar to ACE, all we would say is that we would dilate triangle ABD by a scale factor of 9/5 to create triangle ACE. So let's just check with that. So let's say I did 15 times 9 over 5. Well, I can simplify the 15 to 5. That's 1 and that's 3. 3 times 9 is 27 over 1, so 27. All right, it works. You could have also gone the opposite direction and said that you could dilate ACE by a scale factor of 5 over 9 to get ABD. All right, all you have to do is flip it because you would just flip the proportion. So, how does knowing that triangle ABD is similar to ACE allow you to conclude that BD is parallel to CE? So, we know these triangles are similar. How does that allow us to figure out that these two lines are parallel? So, similar triangles, think about how we did it the first time to show that they were similar in the very first example that we did today. What postulate could tell us that the two triangles were similar? Angle is one of them. Now, remember how we found two angles from the previous example way up here? We could use that to prove that these two sides are parallel to each other. Because if B and C are congruent because the two triangles are similar, and D and E are congruent because the two triangles are similar, so B is congruent to angle C because that's just the definition of similar. And angle D is congruent to angle E, definition of similar. Well, both angle B and angle C are corresponding angles. And angle D and angle E are corresponding angles. We can just tell because they're corresponding angles in the same triangle. All right, not because they're corresponding parallel, they're corresponding within the same triangle. So from that, we can conclude that BD is parallel to DE, not DE, CE. Because corresponding angles of parallel lines are congruent. So that's how we can prove that those two lines are parallel if we know the two triangles are similar. All right, any questions on side splitter theorem? Okay, I know that was kind of a really, for lack of a better word, messy lesson. Does anyone need to see at least one more example on side splitter? You guys get it enough? Okay, so your homework for tonight is going to be pages 11 and 12. All right. So for the rest of the class, you got like a solid 15 minutes. You should be able to get a good chunk of that work done.